We're working on adding our collaborative drawing feature to our drawing program, and we kind of stubbed a lot of things out. I wrote most of the GUI offline because there wasn't a purpose in taking up video time to do that, and then we started doing some of the RMI related coding, adding the remote types, and we pretty much actually implemented the server, mainly because it is so remarkably simple in this code. One of the things that we started writing, but we didn't go very far with, is actually the Sketchable type. Now, turns out that lots of the holes that we need to fill into our collaborator require Sketchable. So it's worth taking some time to go ahead and write this out so that we at least understand what it's doing. So I've made a trait called Sketchable, and I'm going to do kind of two things with this trait. One is we have to be able to pass these around. Remember that in our remote interface we return a sequence of Sketchable. Here we pass in a sequence of Sketchable. If I want to be able to pass things around with RMI, they have to be serializable. So I'm going to say extends serializable. I'm also going to use a feature of Scala that we haven't really looked at, and I am going to make this trait what's called a sealed trait. Now what that does is it means that this trait can be extended, but all subtypes of it must appear in this file. If we try to make a subtype of it in a different file, we will get an error. And the reason for doing this is that I do need subtypes of it, but our collaboration program is going to kind of be dependent upon the fact there's only a certain small number of them. So I'm preventing anyone from accidentally or maliciously trying to create a different subtype of Sketchable to use in ways that we don't want to. Okay, so what should a Sketchable be able to do? Well, it's going to have to be able to draw itself into the main drawing. So I will have a draw method, and it takes a graphics context that it can draw itself to. It returns nothing to us. The other methods that need to go in here are for interacting with the mouse. And really, I'm going to have two types of interaction. So we could have a mouse pressed, a mouse dragged, and a mouse released for this, but I'm actually only going to do the mouse dragged and the mouse released because it turns out that the mouse pressed can use the dragged code for all of the Sketchables that we're going to write. So mouse drag. The goal here is to make it so that we are abstracting the behavior of drawing these Sketchables and of interacting with the mouse so that our code inside of the collaboration client is actually fairly simple. Basically, most of the interaction with the graphics, both for the user events and for the drawing, the details of how different things are drawn and how they interact is going to be inside of this file, which is separate from the collaborator, which actually has to handle the main GUI aspects. So I also want a mouse released, which takes an X that is a double and a Y that is a double, and once again returns unit. So in the GUI we showed four different subtypes of things that we could, or four different types of things that we could draw. They are going to wind up being subtypes of Sketchable. There was the freeform, the line, the rectangle, and the ellipse. And so for each one of those, I want to write a subtype. For the freeform, I'm going to call it a sketch path, because in programming terms, that's what it is. It's a path that we're going to draw. And when we create one of these, we will give it a start location. In fact, this is what's really going to happen when the mouse is clicked, is we're going to construct a new one of these. And a val for red. Now you might wonder, why am I... So I'm going to make a val for red, a val for green, and a val for blue. And you might wonder, well, why are you doing that instead of just putting a color in? Well, remember, color is not serializable. So in order to, I could put a color in, and then I'd have to make it transient, and then I'd have to add the code for serialization. And for doing the custom serialization. And quite honestly, I don't feel like doing that. And this needs to, let's go ahead and let's put a carriage return here. Extends Sketchable. Okay. It's going to need these three methods. And we can go ahead and at least stub them out to make this happy. Save that off. It's happy. Okay, we still have to fill in these methods to make them so they actually do anything, but at this point I'm actually willing to take and copy this and go ahead and create my other subtype. So we have the sketch path. I want to do a line. I want to do a rectangle. And I want to do an ellipse. I might wind up actually I know that rectangle and ellipse are so incredibly similar that I'm just going to hold off. We'll write the rectangle and then we'll see how we do the ellipse. Okay, so sketch line. Sketch line gives us a start and an end. It also gives, oops, I left out something. That's the problem with copy and paste. I have a red, a green, and a blue. I also need a val for opacity, which is a double, because our color needs all 4 of those values. Okay, so we'll start with the line. Drawing. Well, to draw I have my color, but I also have to have a start and an end. And right now I don't have any type of end inside of here. So I'm going to go ahead and add inside of here private var ex and ey are both 0.0. Okay, those are going to be the endpoint. So I have the start point and the end point, and this code is fairly simple. gc.fill equals a color of red, green, blue, opacity. I need to import color, and then I'm going to do gc dot, actually turns out I don't want to fill. I need to set the stroke, because I have to remember that Scala FX has separate color settings for strokes, which draw lines, and fills, which fill in spaces. So we want to go from SX, SY to EX, EY. And that will draw out the sketchable line. The more interesting part of this is really the mouse dragged, mouse released code. So this, when we create it, sets the beginning of our line. And as the mouse gets dragged around, we just need to update the endpoint. So I can say EX equals X and EY equals Y. Okay, so as soon as they drag, it will actually follow their mouse around through the dragging. The released, in this case, turns out to be the exact same thing. Okay, so we start with the line because it's the simplest of them. What about the rectangle? It turns out the rectangle has very similar code to that. We're going to need to have, we get the start position. We're going to need to have an end position, just like we did for the line. And the mouse dragged and mouse released do the exact same thing that they had done before, or at least that they had done in the line. The draw has one line that is almost the same. Because I'm not going to do a stroke of the rectangle, I'm actually going to fill in the rectangle. I need to set the fill color instead. And then I need to draw the rectangle. Now this is where things get a little bit more interesting. Not too bad, but the thing is, when you draw a rectangle, you give it the minimum x and y, and then a width and a height. Okay, so I want to do fill rect, but I need the minimum x and y. Well, I can actually express that as sx min ex. So it'll be the minimum value of those two, and sy min ey for the y value. What about the width and the height? Well, those should be the difference between the two, except we don't know which one's smaller, so we need to take an absolute value. So this will be sx minus ex dot abs and sy minus ey dot abs. Okay. Now, as I said before, I didn't make my ellipse because the ellipse is remarkably similar to the rectangle. Sketch ellipse, and instead of calling fill rect, this calls fill oval. And everything else is going to be the same. The most interesting sketchable is the path. And the way we're going to do the path is it's going to keep a sequence of points in there, and those points will be used to basically stroke out a path. So I'm going to make a private val points, which is a mutable buffer of double double. So we're going, well, double, comma, double. See if I can spell it right this time. There we go. I have to add my import for mutable. Okay. When I have, okay, so what's going to happen with the mouse dragged is, and in fact I can, after I create that, I'm going to say, wait, no, let's just go ahead and create it with our first point in here, which is sx arrow sy. So that's where we start off. Every time the mouse gets dragged, I'm going to add that onto points. So points plus equals s arrow y, and when it is released, I'm going to add that point onto it as well. You know, looking at this code, I don't really think I needed a release to be separate. Every single one of these, the dragged and the released, wind up doing the same thing. So we could come back and refactor this code to simplify it. Basically have a mouse action type of thing. I don't know what we'd want to call it. So the last thing we need to do is be able to draw out this path. So we're going to set the stroke. I already have code for this, building the color down here. So we'll go ahead and pull in that. And then the graphics context has a method called begin path, which starts off building a path for us. Move to, and actually, yes, I do not want to set the start location into here because I am going to use it as just where I move to initially, and then I need to run through all the points and do a line to them. And I think the easiest way to do that is x, y in points gc dot line 2 xy gc dot stroke path. Okay, so we have our 4 different types of sketchables. They're not integrated into the client yet, but that's what we'll do in the next video, and hopefully that'll give us enough that we can actually test to make sure that they're working and doing what we want.